Independent t-test. This is what you're going to be tested on. You got to know for an independent t-test that you have to have one IV with two groups, and that's going to be our university, where 0 represents Dunstown students and 1 represents Sussex students. Remember, that is your grouping IV. You got to have 2 separate groups, also called levels. So we got 0s means they went to Dunstown, and 1s means they went to Sussex. So we're going to see if there's a significant difference in exam scores between which college they went to. So we're going to go to Analyze. Compare them means independent sample, also called a two-way t-test. So our grouper is university, and we're checking to see if, let's do right-click, if there was a significant difference in exam scores, but you have to define the numbers. So our first group was 0. And our second group we mark with a 1. It really doesn't matter what these numbers are. Click OK. Click OK again. So you're going to get the output here. Hold on a second. Get up there, you. Of an independent t-test. See that? So there's the means between the two. There is the first, you got to know this first box test for homogeneity variance. A lot of people get that screwed up. But to check the actual t-test, you go to the T. There's the degrees of freedom. So that tells me right off the bat, I know what the sample size is. Degrees of freedom is the total number of people minus the number of groups. So we have 100 people in this study, right? 100 minus 2 groups is 98. And the sig value is 0.086, but it's a two-tailed. So if we didn't care who scored higher, this would be your answer, and there would be no significance. But if this was a one-tail, example, if we expected Sussex to score higher, we would have to divide this by 2. So, and there would be a significant difference. So I need you to know that as well. All right, MGZ out.